now we will move into another set of program, which is the product of the digits. So write a program to input a number and display the product of the digits. Product of its digits. Okay, now this program we will first of all solve with function procedure, and after that we will solve using sub procedure. Okay, first of all using function procedure. Okay, as usual, what we have to do is we have to declare first of all. So declare function. Now instead of sum, I will replace this name with product, as we are doing product program now. So we need one number. So for that we have one parameter n, then we have CLS, then we have input, then we have this statement. So we have to call the function procedure. Okay, let's talk about this $sign also. Now this particular program is going to print product of the digits. Now suppose if user gives 1 2 3 4, then our output should be 4 3s are 12, 12 2s are 24, 24 1s are 24. So our output has to be 24. And if we look at our output, it is a numeric value, which is the product of the digits. Since this program displays a numeric value will be returned by this function product. Hence $sign is not required. Okay, so after this, now let's change our message. That is, okay, the product of the digits is, now let's call, which is product. Okay, so this is the end of our main module. Now let's go towards the definition part. Okay, product, product. Now in order to solve this program, what we'll do is we have to again form a loop, which is this same loop. Then what we'll do is we again follow those three processes. The first one is we will extract. First of all, we'll extract the last digit. Once we have extracted last digit, now this time what we will do is we will find the product of the digits. So in order to find product of the digits, we have to replace this addition symbol by multiplication symbol. And to store the product, what I'll do is I will use variable p. So since we are using variable p to store the product, it is repeating twice. And what we want to multiply? We want to multiply the digit, extracted digit, and the extracted digit is stored in R. Hence we are multiplying with R. Now after this, whatever digit we have extracted from this particular statement, we have to remove it. And in order to remove, we are using this particular statement, that is n equals to n/10. So within this loop, what will happen is all the digits will get multiplied with each other, and one final product value will be stored in this variable p, and that variable p we have to return. And to return, what we'll do is we'll use product, product, name of the function, and the value which is stored in p. So this is what we have to do. So let's run this program. Now the output should be 6, 6 1s are 6, but the output is, it is displaying is 0. Now our program looks like it is not correct. But if we look at our program, it looks like as if everything is all right. Okay, what we have done is we have formed a loop. Yeah, this is the loop we will be using, because until and unless the value of n becomes 0, we have to continue the loop. And inside loop, we have extracted, we have multiplied and stored in this variable p, and we have removed the digit as well. But the problem right now is, let's see what is actually the problem. So let's trace this program and let's find out the problem. Now let's say user type 234. So 234 will be stored in n. Then now condition checking will take place. 234 not equal to 0 is true. We go to this line. So R here, last digit is extracted, which is 4. So 4 will be stored in R. Now we have variable p. So p is equals to p into R. Now as p has this p has just come over here right now, so the initial value of p is 0. It has not been initialized, so its value is 0. So 0 multiplied with r, what is r? 4. So 0 multiplied with 4 is 0. So the value of p is again 0. Now n equals to n slash 10, we'll remove the last digit. So last digit 4 has been removed. When will again take us to condition. 23 not equals to 0 is again true. R equals to n more 10. Last digit is extracted, that is 3, and stored in R. P equals to P into R. So we have variable P, which is 0, and 0 into 3 is also 0. So again, P holds value 0. Now next time again 2 will be extracted. 2 will be extracted. It will be multiplied with P. P is 0. So again it will be 0. And that's why our answer, it is showing also 0. So in order to prevent this, what we have to do is we have to initialize the value of P. Now initialization of value means we have to keep some number in variable P so that we can prevent it from being 0. And the number that we will initialize with has to be 1. It has to be initialized with 1 because 1 multiplied with any number is the same number. Okay, now whenever we use p equals to 1, let's see how our output works. Okay, now suppose this is the number 234. So now what will happen? Let's see. At the beginning 234, we are assuming this number that the user has typed, that will be stored in n. After that, we have p equals to 1. So we have a variable p that is equals to 1. Then we come to the loop where condition checking will take place. 234 is not equals to 0 is true. Then we come to this line, that is r equals to n more 10. Now this will return the last digit. Our last digit is 4. Then we have this line, p equals to p into r. Okay, now listen, p is 1 and r is 4. So 4 ones is 4. Now 4 is the first digit that we have extracted. So what we have to store? We have to store the same digit. So because of that reason, we are initializing the value of p as 1. If we don't initialize this, then value of p will be 0. Then we have already seen the result. What will happen? It will display 0. So the product of the digits is 0. That's what it will display. Now, if we initialize p with any other number, let's say 2, 3, 4, then what will happen is whenever it comes to this statement, this p will be 2, r is 4. So it will become 4 to the 8. 8 will be stored in p and we will not get the correct output, or our result is not going to be correct. Hence, in order to prevent all those things, we have to initialize the value of p by 1. So this is the reason we have to do p, we have to set the value of p as 1. And you can remember in this way, whenever you are doing, usually whenever we are using this product, whenever we do product program, then usually whatever variable we use to store that value, it has to be initialized with 1. Now we will see this particular similar kind of program. It will come in a, it will come later. Okay, and I'll relate this program with that program at that time also. Okay, so just remember this thing. So where we are, okay, we have p equals to 1, r equals to 4. So okay, now we are in this line, that is p is 1, r is 4, 4 ones are 4. So the new value of p is 4. Then we have this line, n equal to n slash 10, last digit will be removed. Now 4 is removed. Then we have when will take us to the condition. Okay, 23 is not equals to 0. Again, our condition is true. We come to this line, r equals to n more 10. Now n is 23. When it is divided by 10, remainder will be the last digit, which is 3. So 3 will be stored in R. Okay, now we come to this line, that is 4 3s are 12. So 12 will be stored in P. So we have 12 over here. N equal to n slash 10. This will remove the last digit. 3 is gone. When will again take us to condition. We have 2 over there. So 2 is not equal to 0 is also true. So we have this line, that is R equals to n more 10. N 2 is, now we just have one digit, so same digit will be extracted and that will be stored in variable r. So we have 2 over here. P equals to p into r. So 12 into 2 is 24. So we have 24 in variable p. N equal to n slash 10. So this will remove the last digit. So there is only one digit, which this will be removed, and there will be 0. So 0 will be stored in n. Now again we have went. When will take us to the condition. Now condition checking takes place. 0 is not equals to 0 is false. Hence our loop will terminate, and termination of loop means our control will go below when, and below when we have this line, product equals to p, which will return the value which is p, and p holds 24. 24 will be returned. It will go in the main module. Our control will go in the main module and will get printed from here. And after this, it will come to this end line, and our program will finish. So let's run our program. Let's see the output one more time. It is 24. So this is our program for product of its digits using function procedure. I hope this is clear. Okay, now after this we will move towards another set of programs, that is the reverse of the number. Whatever number user gives, what we'll do is we'll display the reverse of that number. Okay, let's go to the main module and let me write down the question first. Write a program to input a number and display the reverse of, and display its reverse. Okay, and display its reverse. Okay, for instance, if user types 1 2 3, then what we have to display is we have to display 3 to 1, because the reverse of this number is 321. It is simple to be understood. Okay, so this is what we have to do. Now the first thing that we'll do is we'll solve this program using sub procedure. So declare sub. Now this is a reverse program, so let's write reverse as our sub procedure name. Reverse. Okay, and n, as usual, we have to take one number as an input. So to store that number, we are using variable n as our parameter. Now we have CLS, we have this. Now we just need to call the sub procedure, which is reverse. Okay, our main module is all over. Now what we have to do is we have to go to the definition part and write our actual code. So let's go to the definition part. Let's replace this with reverse. Now to reverse, what we will do is okay, to reverse. Okay, let's say that user has typed 1 2 3. Okay, now what we have to display is, as we have already known, that we have to display 3 to 1. So what we will do is, the first thing that we'll do is we'll extract digits from the last. So what we'll do, we will first extract last digit. Then what we'll do is we'll store the extracted digit. We'll store the extracted digit in a separate variable, in a separate variable. Okay, these are the steps that we'll be following. We'll extract the last digit, then we will store that digit in a separate variable. Okay, here is variable. Then what we'll do is, yes, we will remove the last digit. Okay, so these are the three things that we will be doing, and obviously all these three things we will be doing inside a loop, and loop is while loop, and our condition, as usual, it is the same. Until and unless the value of n is 0, we will continue these three steps, and we will extract the last digit, we will store the digit in a separate variable, and we will remove the last digit. So our loop, okay, we have already understood about our loop. Extraction of digit, it is the same thing. What we'll do is r is equals to n mod 10, which will give us the last digit. And in order to remove the last digit, what we'll do is we will use the same statement, that is n is equals to n slash 10. Now the only thing is this part, how to store the digit in a variable. Okay, so this is the only thing that we have to know. So in order to store the last digit, what we will do is we'll use a separate variable, and the variable which I usually use is rev. Now for reverse, I'm using variable rev. Now we can't use r because r we will be using to store the extracted digit. Okay, if we use r over here, then we have to change this. But if in both the cases, if it is the same variable, then our program will not work properly, or we'll get some uh, unwanted result. Okay, now now what we'll do is we'll see how we can store the digit. So in order to store the digit, what we'll do is, okay, we'll use one variable which is rev. Now since we are trying to store our digits in this rev variable, it will repeat. So we have this repetition, that is rev is equals to rev, and what we'll do is we'll multiply this by 10 and we will add the digit, and our digit is in variable r. So this is the statement that we'll be using. Now just see this statement. This is rev is equals to rev into 10 plus r. Now we'll just write everything in our editor and we'll trace our program. Then you will understand why we are doing all these things. Okay, so let's move towards our editor. So here we have our editor. So this is our main module, which is already ready. Now we go to the definition part. So the first thing, so what we have to do is, okay, we have a loop, that is while loop is there, r is also there. Now the only thing that we have to do over here is we have to replace this. rev is equals to rev multiplied with 10 plus r, then we remove the last digit. So within this loop, that is within this while when loop, all the digits will be reversed, and it will be, and the reverse number will be stored in rev. So the reverse of the number, that is the reverse of the number is, so the reverse of the number is, it is stored in rev. So let's just run our program first and let's see the output 234. And what it is displaying, it is displaying the reverse of the number is 0. Now let's can you find out the problem, what is happening over here? Just see this program. Okay, the problem over here is, what we have done is we have written rev is equals rev into 10, but here we should actually add, but instead of adding, what we did was we multiplied. That's why this is becoming incorrect. Okay, so okay, let's run our program one more time. 234, and our output is 432. So our number has been reversed. Now quickly trace, let's trace our program and see how this number is being reversed. Okay, okay, let's say our number is 123. Now we have variable r. R will hold, now our condition is true, r will hold the last digit, which is 3. Then we have this statement, rev equals to rev into 10 plus r. So this is rev. So actually it is rev is equals to rev into 10 plus r. Okay, let's see. So rev, we have rev into 10 plus r, rev into 10 plus r. So rev right now, it is the first time. Okay, this variable has come first time, it has not been initialized with anything, so qbasic will treat its value as 0. So rev is 0. So 0 multiplied with 10 is also 0. So 0 plus r, what is r? R is 3. So 0 plus 3 is 3. So we have 3 in rev variable. So this value will be stored in rev. So we have 3, and 3 is stored in rev. Now n equal to n slash 10, it will remove the last digit. So 3 will be removed. When will take us to the condition. 23 is 12, sorry, 12 is not equals to 0 is true. R, it will hold the last digit, which is 2 right now. Again, this statement, that is rev is 3. So 3 into 10 is 30. And 30 plus 2, r is 2. So 30 plus 2 is 32. So 32 will be stored in rev. So we have a new value, 32 over here. Now n equal to n slash 10 will remove the last digit. hence 2 will be removed. When will again take us to the condition. So condition checking takes place. 1 is not equal to 0 is also true. We have this statement which will extract the last digit. There is only one digit, so 1 will be extracted and will be stored in R. Now this statement, that is RAV into 10. RAV is 32. 32 into 10 is 320. 320 plus 1 is 321. And 321 will be stored in RAV. N equal to n slash 10. It will remove the last digit. There are no more digits. Value of n will be 0. When will again take us to condition. Condition checking takes place. 0 is not equals to 0 is false. So our loop will terminate. Our control will go below when, and it will display the reverse of the number is 321. So this is how our output is being displayed. So 321. So now this time what we will do is we will convert the same program using function procedure. So let's do using function procedure. Okay, the first thing that we do is we declare our function procedure. So we write declare function and we write reverse. Now, whenever we write program using function procedure, we have to talk about the dollar sign, whether to keep it or whether to ignore it. Now, in this particular program, our output is going to be the reverse of a number. So, which is simply a number. And whatever our program displays, that is what our function is going to return. So, our function reverse is going to return a numeric value, which is a reverse of a number. Now, since function returns a numeric value, we do not need dollar sign. So dollar sign is not required. And let's give parameter, and our parameter is n. This parameter we are using to store the number given by the user. Now let's write CLS and let's input. So input, enter any number, and whatever number user uh, gives, that number will be stored in variable n, which is going to be the argument. And in order to call, we use print keyword. We write reverse, and our argument is n. Now this is all we have to write in our main module. So we stop our main module or terminate our main module with end keyword. So here is our end. So this is our main module. Now after we have written our main module, let's go towards the definition part. Function reverse n. Okay, now all the steps that we had followed to reverse using sub procedure, same thing we will be doing using function procedure as well. So in sub procedure, what we had done was we first of all formed a loop, and our loop was this one and this is the same loop that we have done in many other programs as well, like in programs like sum of the digits, product of digits. It was the same loop. So that is the same loop that we'll follow. And inside this loop, we will be doing three things. In our while doing program using sub procedure also, we did three things. And those three things were, first of all, what we do is we extract the last digit. So this is the first thing. And secondly, what we'll do is we will store the last digit in a separate variable. And thirdly, what we do is we remove the last digit. So these are the three things that we will be doing over here also. So how to extract, how to store, and how to remove, we have already discussed in sub procedure part, so that it is the same statement. So let's go to our editor and let's write. So in order to extract, what we do is we use variable r, and we divide variable n by 10. But what we do is we do the modular division, and this is also the same statement that we've been following from sum of the digits, product of digits program. It's the same thing. Now what we have to do is we have to store Now in order to store, we use variable rev, and rev has to be multiplied with 10, and what we have to do is we have to add the last digit, which is r. So this is how we store our last digit. And finally, what we have to do is we have to remove the last digit, and in order to remove the last digit, we do integer division, and it is n is equals to n slash 10. And this is all we need to do. We write when to end our while loop. And if you remember, what I had told you was these two lines will be the same, that is the first two lines, and the last two lines is always the same, and whatever change takes place, it is only in this particular part. So while storing, we have to store in this way: rev multiply with 10 and add r, which is the last digit. So we have done everything, and within this particular while when loop, all the digits will be reversed, and the reversed number will be stored in rev variable. So that's what we have to return, and in order to return, we write down the name of the function, which is reverse is equals to rev. So this is how we reverse, and whatever, no, this is not how we reverse, but this is how we return the value, and whatever we return, that will go towards our main module, and it will get printed from here. Now here, what it is returning is, it is simply returning a number, but it doesn't return any message. So what we have to do is we have to write message over here. So the message is the reversed number is, so okay, I'm writing like this, the reverse number is this one. So so here the return number will be kept over here, that is that return number will overlap this particular part, and because of print keyword, this whole statement will be displayed. So here is our output, that is 1 2 3. Our output is 3 to 1. Now suppose it is 1 2 3 2 1, then the reverse is also the same, so it is the same number, and such kind of numbers are said to be palindrome. Okay. Okay, now quickly trace our program and see our output. So at the beginning, value of n, let's say it is 123. Now we come to the loop part, and first of all, the condition checking will take place. So 123 not equals to 0 is true. Now since this condition is true, our control will go to the body part, where it has three statements, and the first one is r equals to n mod 10. So we have a new variable r, and this particular statement will extract the last digit, and the last digit is 3. So 3 is extracted and will be stored in variable r. So r will hold value 3. After this, we come to our second statement, which is rev is equals to rev into 10 plus r. So here storing will take place. So let's see how storing takes place. Rev at the beginning, okay, we have a new variable rev. Rev at the beginning, it has nothing. So qbasic will treat it as 0. So 0 multiplied with 10 is 0, and we have to add r, and r is 3. So 0 plus 3 is 3. So rev gets a new value 3. So this is how storing takes place. N equal to n slash 10. This will remove the last digit. So 3 will be removed. When will again take us to the condition. Condition checking will take place, where 12 not equals to 0 is true. 12 not equals to 0 is true. So again we go towards our body part, and here we have r equals to n mod 10 as our first statement. So here last digit will be extracted and will be stored in variable r. So r will hold value 2. Then we have this statement. Now rev is 3. So 3 into 10 is 30, and 30 plus r is 2. So 30 plus 2 is 32. So rev gets a new value 32. So this is how storing takes place. At the beginning it was 3, 3 got stored, then it was 2, so 2 also got stored. We have 32. Now we come to this line, n equal to n slash 10. Now this will remove the last digit from n, and 2 will be removed, and only 1 will be remaining in variable n. Now we have when will take us to the condition, and our condition is true, because 1 not equals to 0 is also true. So We go to the body part. Now here, extraction will takes place. So 1 will get extracted and that will be stored in variable R. So R will get a new value 1. Then we have the storing line. So REV is 32. So 32 into 10 is 320. R is 1. 320 plus 1 is 321. So we have a new value 321 in variable REV. Now this line will remove the last digit. Now we just have one digit in n, so this will be removed, and instead of 1 we have 0. So 0 will be stored in n. When will again take us to the condition. Now condition checking will take place. So where we have 0 not equals to 0 and 0 not equals to 0 is false. And once our condition is 0 not equal to 0 is false, and once our condition is false, our loop will terminate and our control will go below when. And we have this statement which will return the value that is stored in REV. REV stores 321 and 321 is returned. And it will is returned to the main module and it will get printed from here. So here is the output 1, 2, 3. It is 321.
Thank you so much for watching. Please do like my video so that I get motivated to create more of these videos. We would appreciate if you would share this video with your friends. And if you have any queries and suggestions, let me know through the comment section. Lastly, please do subscribe my channel and press the bell icon so that you get notified every time I post a new video. Thank you.